replicating makerspace. It's like, well, we started running out of rooms for printers, so we printed a new room. And then we had that room print an even bigger room. We just decided to go up. We have like a couple of student workers that are just working a pulley system for the elevator. It's like, oh, not Lippman again. Bring in the heavy crew. But I thought this was a really cool setup for being able, because I know UWM, you have to physically go to their printers. Marquette, you have to physically go to their printers. Wouldn't it be cool to be able to send a print from anywhere on campus? I mean, it has its own thing we have to kind of maybe figure out, authentication or something like that. But and also like what happens when a spool runs out. So all sorts of things like that need to be figured out. But just from a strict convenience perspective, I mean, at this point, the worst that happens, you send something to the printer, it runs out of filament, and it does a 100% invisible print, right? You know, it goes through the motions for 5 hours, and in the end, you have nothing. Not as is. The server supports it, but the machines don't. Yeah, so these are $320 Ender 5 printers. And we might get a couple of larger format ones as well, but we at least want to have like basically a 3D print lab where we can have a bunch of stuff printing.
Are we able to calculate how much filament to use?
Yeah, actually, so like for instance here, if I just go to, here, we'll open up this printer right here.
This is the length of filament.
Yeah, here, I'll just print out this one again. So I've already uploaded this Ender 3 spool plug. This one plugs into the end of the spool holder that's already there. So I'll just tell that guy to print. So now it's printing. It'll be done in 1 hour. And it's using, does it tell me the spool? Or did it tell me the spool length?
Filament has a length there in millimeters.
Oh, yeah, but somewhere I think I can set it to actually tell you the price instead.
How does it, like, does this support add-ons? Like, could we add our own?
It might. I think it's pretty flexible. Lets you do a lot of different things. So the one that I'm printing on right here is this guy. So if you remind me before, middle of class or something, or near the end of class, I'll flip back over to this and we'll see how much it's built up since then. Because it's preheating right now, so it's not actually doing any movement and stuff. But
then when it's done, like, are you need to like come over and remove it and then put another in before?
Yeah. Otherwise, you'd be trying to print on top of something that's already there, and the thing's gonna start smashing into it. I mean, you have I would say it's at least a 25% chance that the print head moves hard enough that you might knock the current print off and still result in a successful print. Just kind of side swipes it. You just kind of surround your printers with baskets to catch the. That actually is not a horrible idea.
That's assuming the print is like high enough that it can actually get knocked by it, and not just dinged by the
extruder.
Yeah,
It just melts there.
yeah.
We really do need, once we have this whole thing, we need to have a goal of printing like a 3D printed tiny home.
3D print a 3D print.
That'd be cool.
Well, that's already a thing.
Yeah.
Yeah, oh yeah, that's common. Yeah, you're way behind the times. People have been 3D printing 3D printers for a while. All you need to do is buy an extruder.
It's not to do with 3D printers. We print more 3D printers.
Yeah. But at this point, $320 for like a workhorse printer, that's pretty good. So, okay. So let's see. Let's look at the homework for today. I think maybe on Wednesday I might go over the exam since I won't be giving homework over break. So let's go. Oh, you want homework over break? I can do that.
No,
Sure, I'll stay on campus anyway.
I already have enough to do over break,
Oh my god, I need to go to work.
including government stuff.
Breaking is so
Oh, that's a good point.
How long is it?
Thursday, Friday, it's 4 days.
Are you going on a cruise right now?
No, I'm just going to Fort Lauderdale for the weekend.
Oh, so you're gonna be here on Thursday and Friday?
Is that for? No, I'm going like a long weekend. So Thursday, Friday, Saturday, Sunday. I'll be in Florida. Okay. Does this version have? What did we write last time?
Question. Yeah, we wrote questions.
No,
Block and define.
No, that's what's for. That's what's due for today. Okay. Yeah, this has my question in it. For some reason, Dr. Racket had crashed, so it's but I have my question logic in here.
Well, this is why we leave comments.
And do I actually have? Yep, there's my question logic. Okay, so for today we're writing block expression and then define expression. So maybe write define first. That just lets us put something into the environment. And did we plan out what that guy looks like?
Yeah, it spits out true or false, depending on whether or not it put it in the.
Okay, so it's a remember expression, right? So in our grammar, remember expression is maybe going to be the word remember, followed by a, I'm going to go ahead and write as it actually would be. So this guy's going to be a symbol, right? And then followed by a, we'll say lambda calculus expression, something that boils down to a value. If you notice, one of the questions on the exam was about why might we want to store lambda calculus, or why would we want to store lambda expressions in our environment? Well, if you go back to like a Java program, and I think we looked at this in class at some point. We'll just Yeah, this was actually really cool in the 548 class the other day. We implemented composite memory, horizontal composite memory, which gives you the ability to hold really big values. So you have horizontal and vertical organized memory. So you know how in like Java we have a limit for like size of int or size of long, and eventually we run out of stuff. Well, with this, you can say, I want to store this gigantic crazy number that is limited only by how big a string is. And then what it does is it actually splits it into binary and stores it across a whole bunch of, we created a generic memory module. This emulates what a memory looks like inside of a computer. And then we have composite memory. We would take a whole bunch of those chips and link them together, because it's easy, it's cheaper to mass produce a memory chip than to mass produce 64 gigabyte chips, something like that. And we were able to just have these crazy long numbers that, which is useless, right? Because there's a point where we no longer need, and there's big integer already built into the language. So I mean, we already kind of had this ability, but this actually stored it like real memory, which was awesome. But it allowed us to store arbitrary size numbers in binary and recreate them on the other end. It was pretty entertaining, actually.
Do you have to manually store like pointers in C or
What do you mean manually store?
like if you were to use this, your
Yeah, so here's like the composite memory write.
yeah, so you have to flip it right,
Yeah, you just write from it, and then you can read from it. It gives you a giant value.
Is there a way that you could just like run a standard Java thing, I guess, file, where it would just automatically write to it, or?
Well, I mean, this effectively is an object that knows how to hold giant numbers.
Yeah.
So I mean, we implemented memory in software, composite memory in software. So I mean, this is named something scary, but this really could just be called big integer. So it's like I put a big number in there, I can get a big number out. There's already a big integer class. It just happens to be that under the hood, the way this is implemented is how actual memory works in our computer architecture. But it was pretty entertaining. But in any case, with like a lambda expression, This is a variable name, is it not? Spread out. And this is a lambda, is it not? A lambda is an unnamed function. Now it has a name. Name, value, pair. This is the name. This is the value. So up to this point, our values are all numbers. But wouldn't it be handy to be able to have a value that is a lambda that we can associate with a variable name that we can then use with an app expression or something like that? Make sense? All right. So let's go back to just
So to clarify that, we could use the remember function to remember a block function and therefore essentially make functions in our own language.
You could, well, yeah, but you would use the remember function to remember a lambda expression, and then you would use it inside of a block.
Okay.
Inside of a block, you would have an app expression that the first element of that app expression. Remember, our app expressions are a lambda calculus expression followed by 0 or more lambda calculus expressions, right? And right now we're presuming the first element of that is always a lambda. Well, now it could be a var expression, right? That boils down to the lambda that var expression. So now we would say we assume it boils down to a lambda. All right, so remember expression is going to have the word remember, followed by the variable name, followed by the value. That's what that guy's going to be, right? All right, so we'll go into this guy. Also, midterm grades are, so right now your weighted total is equal to what your midterm grade is, and they're submitted, so I don't know when the registrar runs that report and sends them out, but soon. Exam grades were all over the place. I think there were several 100s. I think the low grade was like a 7. Yeah, it was impressive. I mean, to earn a 7, that means you filled in the exam. Huh?
There were 10 questions.
Yeah. Every one of them had content.
Would it be 10 points?
Huh?
Wouldn't it be 10 points?
No, you don't automatically get a point just because it's a question. So you're saying if you like drew a smiley face, it's like, well, that's worth 1.
Made an attempt.
I mean, typically the correct answer would be made of like marks of text. On a piece of paper, it'd be pen marks or pencil marks. This is pencil marks that, if reconfigured, might lead to a close answer. No, I will. I give significant partial credit for competence, and I give no credit for complete incompetence. I'm not gonna hunt down and say, well, he used an opening parenthesis. Funniest answer I had on all the exams. And this person's here, and they can own up to it if they want. I think it was the last exam on the test. And it was like, I have a call from work, I have to go.
It's true. I was doing my exam, and then I had a call, and I was like, I have to take this. And I was like, I don't know if I leave this open, because I was getting close to, I think, the time limit. I just wanted to submit it. So I was like, oh, I guess whatever.
The answer to his question is, I gotta go.
Just like, all right, we're done.
Yeah, that was really funny. It's just like, look,
I didn't want to just leave it blank. I figured you'd get a kick out of it.
I did get a kick out of it. It's just commentary. It's like, look, I just don't have time for this question. I gotta go.
What was the question? I don't know.
I think it was the very last one. It was
Yeah.
Okay.
He's like, I'm out of here. All right, so we're gonna build a remember. I'm gonna go ahead and put our remember expressions near our var expressions. Kind of makes some sense, right? So we're going to define a remember exp to be a lambda that's going to take in,
First night of September.
huh? Who?
It's remember, so it takes in the 21st night of September.
Oh, haha. So this guy's going to have two parameters. So we're going to take in a symbol and a var. Actually, we'll call it symbol like we did for our var expression. All right, so this guy will take in a symbol and a lambda calculus expression. And then what we'll do is we'll create a list out of remember the symbol and the lambda calculus expression. That's our constructor. All right, then our test for this, define remember exp takes in a lambda LC expression, and this returns EQV remember car of LC expression. With that, yeah.
This is kind of an aside question,
Mhm.
but why can list take in any number of parameters when, like, inside of scheme, a function can only take a certain number of parameters?
You actually can, there's a way in scheme to have it, to define how to take in more than one parameter. Like you can
There
say,
is, but we can't use
yeah,
it
we
with
haven't,
our setup.
yeah, we haven't, it's not one of the teaching languages, but it does exist in scheme. I think it's, I think the underlying construct in scheme is called streams that uses that. That could be wrong because that's a pretty dated piece of memory I just pulled up, but I'm almost positive it's called streams. Okay, so now we can build a remember expression, and we can ask if something is a remember expression by seeing the car of it. And this presumes we're going to call it in an order where that guy is a carable thing. It's a list with something in it. And looking to see if, did I spell remember right? There's some real risk there, Blaine, so you're going to stay on your toes. Remember just seems like a misspelling waiting to happen. We want to have meaningful variable names. Okay, so then we'll go right after our var expression up here. So we'll say if this is a question expr, if that's the kind of thing I'm looking for. Oh, thank you. See, I just Xeroxed. That's what I did. I copied what I just did. So then we got a question mark, remember exp. Does Xerox still exist as a company?
I think so.
Yeah.
They're printers, right?
Well, they are actually the company that made the first computer with the a mouse.
Wow.
Then decided not to bring it to market, invited the Apple people in to share all their ideas with, and Apple released it as the,
Lisa.
yeah, Apple Lisa.
And now they just make printers or Xerox.
Yeah, well, the real money's in printers, not computers.
Ink, yeah, he's right.
Yeah, the real money is in ink. That is true.
Yeah, I can spend $60 for a printer or $50 for an ink refill.
That is the world we live in now. In fact, we have whole businesses built around like refilling ink cartridges, right? What's the name of that the company? They have whatever, you know what I'm talking about, though, right? There's it's kind of like batteries, etc., but there's one for printer ink, where you take your cartridge in there and they refill it, and at a presumably much lower cost than it would be to get a whole new print cartridge with the new print head on it and all that stuff. All right, so if I'm looking at a remember expression, what do I ultimately want to do? Well, I want to extend my environment, and then what, probably return that environment? Reasonable enough thing to start with, because we are going to have to deal with some compatibility thing here, right? So I have this idea. I mean, what does a remember expression do? Remember expression says, well, I'm going to make my environment bigger than it used to be with this new name value pair. And then somebody else is likely going to want to operate using this environment. Make sense? All right, so we're going to go ahead and we're going to say, we're going to return extend env just like that. Is that how we wrote it? Extend env, and this guy's going to take in a, well, here, we'll do it as a let, so we have our nice pieces here. So we have a let that's going to take in a, the symbol is going to be the catter of LC expression, or it's not LC expression, it's EXPR. That's our symbol. And then our value will be the CADDR of our expression. Okay, and then we can close that. All right, so then the body of the let, actually, is this the way I've been writing them, or do I write it like that?
Yeah, like that. That was different.
All right, so then inside this, we're going to say extend env to take in a symbol as well as apply expression, passing it the value in the current environment along with the current environment. So remember, exp is ultimately going to result in an extended environment with this new variable name whose value is the result of calling apply expression on the lambda calculus expression part of my remember in the current environment. So this guy's going to boil down to a value. So at this point, we're presuming this guy's probably a lit expression right now. And then the environment we're extending is env right here. Go ahead.
So that's actually kind of part of my question is how are we going to store lambdas with this? Because this works well with lits and variables, but if we have a lambda that we're storing, we're going to resolve that lambda down to whatever number it's supposed to resolve to, or our
No, we won't. We might choose to store a lambda in an unapplied format, still in a lambda exp format, only to be applied in the context of an app expression. So it's a little foreshadowing. So in this case, I'm always applying my expression. I'm always saying, if it's a lit expression, give me the 5 or the 4 or the whatever. If it's a var expression, give me whatever value it resolves to. If it's a lambda expression, just keep it. I want to store this exact expression because I'm going to use this expression later inside of an app expression to apply it to some parameters. That makes sense? So we would choose not to actually apply it. So remember that when I give you the assignment for adding lambda expression support to our language. All right, so this guy makes sense? So this is our remember expression. We can test this dude real quick. So this is going to be a remember exp, and this guy's going to take in an A and I don't know, a 5. Actually, it's going to take an A and a lit exp5 like that, right? And then we'll call our test expression. This guy should boil down to a extended environment that now has an A, a C, and an X in it. So there's our A is 5, there's our X, and there's our C. So far, so good. All right, so remember seems to do what it was supposed to do, and that is toss some stuff into our environment. Okay, so now let's think about block expression. Go back to our this dude. So a block expression is going to be block followed by a collection of, so we're going to say LC expression. Now we could say you wouldn't have a block expression without at least one expression in it, but technically I guess you could. So there's a block expression with 0 or more lambda calculus expressions, where the result of a block expression that had no lambda calculus expressions in it would be the empty list. I had nothing to evaluate here. Okay. That makes sense? So to build this guy, we'll go up to our constructors. We'll just go right after our remember expression, and we'll do define block exp to be a lambda that's going to take a list of LC expressions. And this guy is going to return the append. Actually, we could just return the cons of block onto the LO LC EXPR. Like that. So that'll just take whatever list you gave it and just throw the symbol block on the front of it. Now it's a block expression. Mm-hmm. All right, and then we'll do a define block exp question mark. This is a lambda LC expression. And we'll return EQV block car LC expression. Like that. All right, so far so good. All right, so now we'll go and tack this guy onto our code. And we'll put it right under our remember expression just because. So we'll say block exp, expr, if that's the kind of dude. By the way, what I'm doing right there is the exact reason why we have our predicates. So now you're seeing it in practice rather than just hearing me say the sentence. I'm adding block expressions to my language. How do I do that? By just putting the predicate for block expression in there. Isn't that very simple? I don't have to have all the EQV crap in there and stuff like that, even though we know that's what's hidden behind this. We know this guy's a lambda calculus expression that's doing whatever that magic is. But now I could just ask this question like this, and now this dude looks just like my grammar. Speaking of which, another question that was often missed on the exam was grammar versus production. This whole thing is a grammar. Each of these lines is a production. So a grammar is a set of a collection of productions or a collection of rules that describes a formal language or that formally describes a language. Not necessarily a programming language. You could have the grammar of numbers, the grammar of symbols. What's a number? A number is 1 through 9 followed by 0 or more 0 through 9s. Right? That's what a number is. Number means it has to be at least one digit. So but we'll have usually we would say we wouldn't start a number with a 0, but I guess you could have a binary number starting with a 0 and it doesn't break. Like if somebody says, how old are you? And you say I'm 27, you could write that as 027. It's weird, but legal, I guess. So you could just say 1 or more digits make up a number. If you want to keep it simple. So that means the grammar of numbers requires a grammar of digits, which is a 0 or a 1 or a 2 or a 3 all the way up to 9. And then you have a second grammar of numbers, where a number is 1 or more digits. So that grammar has a single production in it. Make sense? So this whole thing is a grammar. Each individual line is a production. All right. What was I doing? Oh, here. Ninja. Here's our print.
Speaking of ninjas, you need to register awesomefat.ninja.
Is there a .ninja
Yes,
extension?
there is.
Yes.
It's not a top level domain.
Same reason .pizza is a top level domain.
No, .ninja makes sense. .pizza does not.
Right.
You could register both.
Do you see how there was no questions? Exactly.
Register both and you're a Ninja Turtle.
Only one of the Ninja Turtles. Which one?
Michelangelo.
Which everybody presumes is my favorite, but he's actually probably my least favorite. It's a tie between him and Raph for who's my. I like Donatello and Leo. Donatello's my favorite. He's the clear winner because he's the smart one. All right, so we have our block expression. What do we do with block expressions? Well, we have a list of expressions represented as the cooter of that guy, right? All right, so we're going to go ahead. I'll just start with a let, but we may upgrade this guy. Well, this will get us our initial environment, then we'll go from there. So we're going to create a let, and we're going to have our list of LC expressions. And this guy is going to be equal to the cooter of EXPR. All right, so that's our let so far, right? We might tack some stuff on there. All right, so that guy is going to be a list containing 0 or more lambda calculus expressions. Now, what I want to do is I want to go through that list, and I want to call apply expression on each one of those elements. Now, an important thing here is we might be coerced, potentially, into mapping apply expression with the current environment across that list. And that would only be accurate in what situation? Go ahead.
There's no like defines inside of the block.
Yeah, no remembers.
Yeah.
If we lucked out and there were no remembers inside of our block, then we would be applying every expression in the context of our
Starting environment.
yeah, in our starting environment, where one remember in there now modifies our environment to be something else. Correct? All right, so we potentially want to have a modified environment. Then I am now having all the other things happening within or something like that. Okay, so we know our current environment is ENV. And we know we want to call apply environment on each thing in there using the current environment unless it's a remember. And what does a remember do? A remember gives us a new environment moving forward. That makes sense? All right, so let's build the generic. And we're going to assume that remembers don't exist, but we're not going to map across it. We're going to write the function that goes through one element at a time and says, if you are not a remember, do this stuff. All right. So we're going to go ahead and I'm going to, do we want to have we'll do a let rec. Let recs are fun. All right. So we'll do let rec. Let
Nope, spelling error.
rec.
Spelling error.
The rest.
Spelling error.
Blaine's in an infinite loop. All right, so we have our
3 hours after. Still sitting here.
we have our let rec here. So we're going to have a why don't we call this guy maybe process, and he's going to be a lambda expression that's going to take in an expression as well as a environment. Start off with that. Actually, for right now, let's just have him take in an expression. All right, so he's going to take in an expression and he's going to do some stuff. All right, so he's going to have, we'll do a con because we kind of like cons. They look cleaner maybe than ifs. So we'll do a con here and we're going to say not, what's it called? Question? EXP. If I'm looking at something that is not a question EXP, then what do I want to do? I want to apply EXP so apply expression. What expression? I'm going to apply the expression EXP in one environment, ENV, which right now the most local ENV is the guy that came with apply expression here, right? Go ahead.
Do you want it to be RememberEXP, not question EXP?
Yeah, Blaine.
Okay, I thought you knew what
This
you were
is
doing.
the second time I did that?
I'm trying to figure out why you're using question. I'm like, maybe
Yeah.
you just know something I don't. I'm just gonna watch and.
Yeah, that's basically what I thought too. I'm like, oh, cool.
What
I'm just like,
strange
this
branching
is-
stuff are we gonna do?
All right, so
We're
we'll
gonna
do.
No. We're gonna have one for Linden Bar. Also, we'll just do everything instead of.
Alright, so if it's not a remember expression, okay, if it's not the type of expression that changes our environment, we're just going to use the current environment. All right, and what do? We call apply expression on the expression that we're currently dealing with in whatever ENV is, which right now is this global environment that's owned by apply expression. It's not changing, right? We'll update that in a moment. All right, that's what we'll do. Now, what we're going to be doing is, I think, didn't we decide we maybe kind of return a list that was a collection of these things? Okay, so, but process in and of itself just takes in a single expression and processes it and gives us the result. Let's just say that that's what that guy does. In fact, well, actually, that's what apply expression already does. So that means that process expression is going to give us our list. So that means we'll go ahead and
Remember expression.
I'm going to throw one more thing in here. That is, we're going to say null EXP. So in the situation that we, so this is really a list of EXPs. Okay, so if null list of EXP, then we'll just end with our empty list, kind of back to one of our old patterns. All right. Otherwise, if not, remember car low EXP, then what do we do? So if the car of low XP, the first list that's in there, the first lambda calculus expression, if that guy's not a remember, then what will I do? I will cons apply expression of EXP on the current environment, whatever that means, onto the result of calling process.
Shouldn't we card all
Yeah. Thank you. I need this guy. That's not a spelling error, it's a logic error. V's in charge of logic errors. You're in charge of spelling errors.
If he's not picking the right guy.
All right, so we're going to cons the result of apply expression on the expression we're currently processing, right? The car of low expression in the current environment, whatever that ends up being. All right, like that. And then we will cons that onto process the cooter of low EXP on that current environment.
No, because the process you only take a list.
Oh, currently, yeah. Not for long. No. But currently, yes. All right, so that's what we'll do if it's not a, yeah, that's what we do if it's not a remember expression. Now, our else means it is a remember expression. And what do we do if it is a remember expression? That means we're going to boil down to, we'll keep it up here for now. Process, we're going to call process again, passing it the cooter of low, ooh, there's no dash there. Way to go, Blaine. Cooter of low expression currently, right? But we have an opportunity here to now extend our environment. So what I'm going to do is I'm going to have our process not just take in a list of expressions, but take in the, I'm going to call it cur ENV. Actually, let's keep it. We've kind of named our stuff like that. we'll call this guy curry env, the current environment in which this guy is happening in, which means that anytime that we are executing something inside of an environment, we're going to be executing it inside of the current environment. All right. So in the event that we are looking at an else where we have a remember, where remember modifies our current environment.
And also then the process would have environment too.
Yes. So this guy right here would be current environment. So process now takes two parameters, a list of expressions and a current environment. So anytime I call process, I'll pass it that current environment. Now, in this else here, where we know our lambda we know our car of our lambda expression is a remember. Then we're going to go ahead and call process. Well, we'll go ahead and cons. Actually, we wouldn't cons because this guy's just going to boil down to an updated environment. So, yeah. Well, inside the process. So we'll go ahead and call process again. Go ahead.
Wasn't it supposed to just add on like a true or something for the remember expression?
Oh, is that what we said to do?
Yeah.
Okay. So we will call, we'll cons a true like that onto the result of calling process on the cooter of our low expressions. That's our new expression. And we're going to go ahead and call apply expression on the car of low expression. Yeah, this is where my remember expression is going to be. So apply expression.
Expression needs to spelled out all the way.
Oh, and low expression where?
No, line.
Oh, this guy. Apply expression on the first guy in the current environment. And he's going to what?
It's current and slash.
Cur dash env. There we go. All right, so we're going to apply expression. What expression? This is going to be our remember expression in this environment. That's going to boil down to an extended environment, which is now going to be our new cur expression that we pass into process. Like that. And we're consing on a true here because we said that remember happened. True remember happened. Okay. Isn't it?
No.
Cons are true.
I mean, it's right under your logic, but on the homework, that's not what you told us to do.
What did I tell you to do?
You told us to say 5 and the thing. So remember, you have remember a equal whatever.
Yeah.
And then the next is like a lambda. So then the split out is 5, which is in already split out the environment. If you just take a look at your test slide, that's
He
He didn't have us return the environment in the output.
No, he made us return the element in the output. I'm pretty sure that's why I get stuck in. But anyway.
I don't think so. Didn't you say I just had to do a true?
Yeah.
No.
True what happened.
Oh, whatever. I'm just going to keep going here real quick. So we're just about done. All right. So else we're going to cons true onto, so you can decide what your output's going to look like. Output's going to be whatever you want it to be in your list. It doesn't matter. The logic is still going to be the same logic. How you want to represent the result of a remember inside your list is whatever. It only changes this one piece right there. What I have highlighted. That's the only thing it changes. All right, so we're going to call process on the expression we're going to deal with, on the apply expression, for that guy, and that's going to give us a list, right? And now we need to then also call process on, actually this is in my else, so I'll call process on the remember, on the apply expression of this guy. And I know this is going to boil down to a new environment, so now I'm going to actually be consing apply expression on the next dude, but only if the next dude exists. Because you potentially could have your very, 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 very last element be a remember. Potentially a waste of time, but it is possible, right? So here, for right now, I'm just going to put a little thing saying last element might be a remember, like that. All right, makes sense? Okay, so so for Wednesday, I'm going to give you a little reading assignment that's going to have you go ahead in the book and look at storing Lambda expressions in our environment. And then we'll come back on Wednesday, we'll finish this, we'll go over the exam, and then when we come back from break, we'll start adding Lambdas to our environment. So I'll put up the reading assignment, but something from the book for Wednesday. Okie dokie, let's check out our print. Still going.
Oh. Anyway, that's kind of scary.
Studying. I was about to say, do you wanna